Hello students, welcome to EPG Pathshala. I am Dr. Renu Tyagi from Sardar Patel Institute, Ahmedabad. Today we are going to discuss about the module Physical Working Capacity under the paper Physiology and Sports Anthropology. So students, let's see what we are going to learn from this specific module. We'll be describing the concept of physical working capacity of an individual. Then later we'll understand the physiology behind the physical working capacity of an individual. Then we'll have a description of the different measurements of the physical working capacity. We'll come to know about the factors that enhance or influence our physical working capacity. We'll try and understand the impact of cardiovascular and respiratory functions during the physical activity. Then in the last, we'll study the importance of the different kind of exercises for the upliftment or for the improvement of one's physical working capacity. Now let's first understand what do we mean by physical working capacity. It's basically can be defined as the adaptation that the individual body responds to the stress of the exercise. The physical working capacity is nothing but our cardiovascular and respiratory endurance. The physiologists have been continuously interested in assessing the working capacity of individuals and thus determining the physical fitness of the population. The metabolic requirements of the body at rest and during the exercise are met by the oxygen supply to our tissues and simultaneous removal of the carbon dioxide from the tissues. This is primarily governed by the cardiovascular and respiratory system mechanism to meet the increasing demand of oxygen to our working tissues during the exercise or during any physical activity. The capacity to breathe, to transfer the oxygen to the lungs, to increase the lung volumes and capacity, to increase the cardiac output, to transport the oxygen by the blood to perfuse the active working muscles and to remove the carbon dioxide simultaneously from the tissues during the conditions like the physical exercise, which can help us to measure the physical working capacity of an individual. Now let's study how we measure the physical working capacity. Physical working capacity is the assessment of the individual capacity to the physiological stress. Thus, the stress experienced by the body can be measured to establish the working capacity of an individual. The stress of exercise is applied to the individual to assess the working capacity of various systems of the body. The physical working capacity is measured by the body parameters like the cardiovascular efficiency, respiratory efficiency and the muscular strength. Now, how can we measure the cardiovascular efficiency? The cardiovascular efficiency can be measured with the help of heart rate, stroke volume, cardiac output, blood pressure and the blood flow. On the other hand, the respiratory efficiency can be assessed by studying the lung volumes, different lung capacities, pulmonary ventilation, oxygen consumption, pulmonary diffusion capacity for oxygen and the muscular strength. Now let's understand the cardiovascular efficiency in terms of the heart rate. The heart rate reflects the rhythmic expansion of arteries as the heart rejects the blood with each beat. It's the number of ventricular beats per minute. Physical efforts cause the heart rate to increase. There is a direct linear relationship which exists between the heart rate and the level of physical effort. The heart rate generally increases and then subsequently diminishes to a lower level, which is maintained throughout the period of exercise during a light exercise. However, during prolonged heavy work, and if the load is heavy, there is a tendency for heart rate to increase with an increase in the duration of an exercise. During the maximum work, our heart rate increases until a state of exhaustion is reached. The terminal heart rate was recorded as the maximum attainable heart rate. The highest attainable heart rate during the performance of a heavy muscular work is a measure of physical working capacity. Now let's understand how the stroke volume can be assessed and how it helps us to measure the cardiovascular efficiency. The stroke volume is the volume of blood ejected into the main artery by each ventricular beat. It is generally calculated by measuring ventricular volume by an electrocardiogram. It is believed that stroke volume was a direct function of the end diastolic volume of the ventricle, which is based on a well-known principle known as the Starling's law of heart. The Starling's law of heart states that greater is the length of the cardiac muscle fiber, the stronger is the myocardium contraction. It also says that an initial length of the cardiac muscle fiber is actually determined by the amount of blood which passes into the ventricle during diastole, which means that the force of contraction determines the amount of blood pumped by the ventricles during a systole. So, the stroke volume is directly related to the diastolic volume up to a critical point. But this greater force of contraction is created in part by an increased stimulation of the heart muscle from the sympathetic nervous system and by an increase in the norepinephrine and epinephrine hormones released from our adrenal gland. In resting position, the stroke volume is about 80 to 90 milliliter, but it can increase to twice the normal value during an exercise. The stroke volume increases rapidly under the physical efforts as a result of greater venous return, which occurs due to transition from rest to exercise. Therefore, it becomes a measure of physical working capacity. The stroke volume depends on our heart rate, therefore, it is larger in males as compared to that in females. An athlete has a greater physical working capacity for not only pumping more blood by the heart per beat, but they also have a greater capacity for extracting more oxygen from the blood into the muscle tissues than a sedentary individual. This could be possible due to a relatively low resting heart rate that increases end diastolic volume, producing an enlargement of the heart and thus have relatively larger stroke volume and hence greater physical working capacity. Now let's see what is cardiac output. The cardiac output is the volume of the blood ejected into the main artery by each ventricle per unit time, and it is generally expressed in liters per minute. This can be calculated by multiplying the stroke volume with the heart rate. At normal or at a resting position, the cardiac output is about 5 to 6 liter per minute, but it may increase up to 5 to 6 times during a maximum physical work, and this is because of an increase in the heart rate and stroke volume during a strenuous exercise. Therefore, the cardiac output becomes a measure of physical working capacity. During the first few minutes of rhythmic dynamic muscular work, the cardiac output increases first rapidly and then more gradually to a new steady state level, which is a function of intensity of work. In spite of the tendency of the stroke volume to decrease during prolonged exercise, cardiac output remains constant on account of an increased heart rate. Our cardiac output does not rapidly return to the previous resting state after stopping the exercise, but it decreases gradually following a exponential curve. Now let's understand the blood pressure and how it can be a measure of our cardiovascular efficiency. As by now we have understood that blood pressure is the pressure exerted by the blood on the arterial system. Blood pressure is a function of cardiac output and peripheral resistance. During a strenuous exercise, the blood pressure increases linearly because of an increase in cardiac output. Exercise affects systolic blood pressure to much more level than a diastolic or our mean pressure. This could be attributed to the fact that during exercise, the resistance to the blood flow is decreased. This decreased resistance is the result of immediate and drastic vasodilation to the resistance vessels of the working muscles and also vessels in the skin. In systemic circulation, the systolic blood pressure increases linearly with the severity of exercise at all ages, and it may increase to 200 mmHg. This increase is due to the increase in cardiac output and vasoconstriction in non-working muscles. In systemic circulation, the diastolic blood pressure, however, remains practically unchanged in mild and moderate exercise because of total resistance falls due to drastic vasodilation in working muscles, though it may increase slightly during heavy exercise due to the vasoconstriction in non-working muscles and skin. Now let's understand the change in blood pressure in pulmonary circulation. At rest, the systolic blood pressure in the pulmonary artery is 15 to 30 mmHg, whereas the diastolic blood pressure is 5 to 8 mmHg and the mean pressure is 8 to 12 mmHg. During a mild or moderate exercise, the pulmonary arterial pressure increases due to an increase in cardiac output and heart rate. This is due to the intrathoracic localization of pulmonary vessels which have a low resistance to the blood flow. Therefore, a several-fold increase in cardiac output with only slight increase in pulmonary arterial pressure is observed. However, during a heavy exercise, limits of vascular compliance are approached and the pulmonary arterial pressure may increase markedly. The blood pressure comes back to the normal within 5 minutes after the stopping exercise due to the sudden relaxation of our muscles which produce vasodilation. The initial increase is due to the sympathetic vasoconstriction. Now let's understand the concept of blood flow to the different body parts during the exercise and how they can be used to study the physical working capacity of individual. Let's understand the blood flow to the various organ systems. The blood flow to the different body systems depends on the response of the stress of our physical activity effort. Thus, it can work as a measure of physical working capacity. The next is the muscles blood flow or the blood flow to our muscles. At resting phase, the blood flow through the muscles at the rate of about 4 to 7 milliliter per minute per 100 ml. This flow increases greatly with the exercise and the strenuous contraction of our muscles, reaching to a level which is more than 15 to 20 times of the resting value, or 100 ml per minute per 100 ml of the tissues. This increase could be attributed to an increase in the capillary density, that is the opening of more capillaries. Thus, an increase of the blood flow to the muscles increases, which in turn increase the aerobic metabolism activity of the muscles and hence greater extraction of the oxygen from the blood. Around 80% of the oxygen is offered to it as compared to the 20 to 25% at the resting state. Now next is coronary blood flow. This is the blood flow to the cardiac muscles. During a muscular exercise where we involve lot of muscles, the blood flow to the cardiac muscles increases linearly with the cardiac output. At rest, the rate of blood flow to the cardiac muscles is about 60 to 70 ml per minute per 100 ml, but during the exercise it increases up to 5 folds above the normal level with 100% coefficient of oxygen diffusion or utilization. This is because of the coronary vasodilation of the resistance vessels by catecholamines. Pulmonary blood flow. So let's come to the pulmonary blood flow. It is the blood flow to the lungs and this increases during the heavy exercise to the extent of up to 4 to 5 times the resting level through more capillaries and through the rise in arterial pressure. The cross-sectional area of the capillaries bed of our pulmonary system increases by a factor of 2 to 3 times during the maximal exercise. This increased velocity of blood flow through the pulmonary capillaries However, at rest, the amount of blood in the pulmonary capillaries is 70 to 100 ml, which is doubled during the performance of any physical work. The total pulmonary circuit contains about 150 to 800 ml of the blood content at rest, but it may rise to 1400 ml or more during a severe physical work. Now let's come to the skin blood flow. The blood flow through the skin is about 500 ml per minute at rest, which depends upon the cooling power of the surrounding air and the overall metabolic rate of the individual's body. On passing from rest to the exercise, the blood flow through the skin decreases in the beginning due to the reflex vasoconstrictions, but increases up to 7 times or as much as blood than at the rest, which is 15% of the cardiac output. Now let's see the blood flow to our visceral organs. The flow to the visceral organs, that is our kidney, liver, spleen and gastrointestinal tract, constrict greatly during the muscular exercise, and thus the blood flow to these organs declines and the volume of blood to the splenic area is reduced. The vasoconstrictions of the capillaries vessels are induced by the heavy exercise, which is related to the intensity of the work. The respiratory efficiency can be studied with the help of different lung volumes and lung capacities. The lung volumes changes considerably with the stress of exercise. All lung volumes and lung capacities can be measured with the help of a simple spirometer. Now let's understand the different lung volumes and lung capacities individually in a greater details. The tidal volume is defined as the volume of air breathed in or out of the lungs during a normal respiration. At rest, the tidal volume is about 400 to 700 milliliters. This decreases due to less contraction respiratory muscles because of muscular weakness or depression of the respiratory center, but it may increase greatly with the muscular exercises. The next volume to understand is the inspiratory reserve volume, that is IRV. It may be defined as the maximum volume of air which can be inhaled after completing a normal tidal inspiration. The normal values for IRV is 1000 to 1400 milliliter. The next is expiratory reserve volume, that is ERV, which may be defined as the maximum volume of air which can be exhaled after completing a normal tidal expiration. The normal values for ERV are generally taken as the 300 to 600 milliliter. Now next is the residual volume, that is RV. It is the volume of the air which remains in the lungs even after a maximal exhalation, and its normal values are 700 to 1000 milliliters. Next is the forced expiratory volume in 1 second, designated as FEV1. It may be defined as the maximum volume of air that can be exhaled in the first second of forced maximum inspiration. The next volume is the minute voluntary ventilation, that is MVV. It is the largest volume of air that can be moved into and out of the lungs in 1 minute by maximum voluntary efforts, and its normal value is generally 90 to 170 liter per minute. Now let's talk about the different lung capacities. The first one is inspiratory capacity, which is IC, and it is the summation of our tidal volume and inspiratory reserve volume. It may be defined as the maximum volume of air which can be inspired after completing tidal expiration. The normal values for inspiratory capacities are 2700 to 3200 milliliter. The expiratory capacity or EC can be represented as the addition of our tidal volume and expiratory reserve volume. It is defined as the maximum volume of air which can be exhaled after completing the tidal inspiration, and its normal values are between 1250 to 1500 milliliter. Now let's come to the vital capacity. The vital capacity is the addition of our IRV, PV and ERV. It is the maximum volume of air which can be exhaled from our lungs by a forceful effort following a forceful inspiration or maximum inspiration. Normally, it's about 3.6 liter. The measure of vital capacity provides a very useful information about the strength of our respiratory muscles. The next is functional residual capacity, that is FRC, which may be taken as the summation of residual volume and expiratory reserve volume. It is the volume of air which is contained in the lungs after completion of tidal exhalation, and its normal value is about 2.5 liters. Another important capacity is the total lung capacity, which is the summation of our vital capacity and the residual volume. It may be defined as the volume of air contained in the lungs after a maximal inhalation, and a normal value for TLC is 6 liter in an adult individual. The last capacity or lung capacity is the forced vital capacity, that is represented as FVC. It may be defined as the volume of air that can be exhaled forcibly and as fast as possible after maximum inspiration. Now let's study the concept of pulmonary ventilation. It is the volume of air inspired or expired by the lungs in 1 minute. It is generally represented in terms of the tidal volume and respiratory rates, which is the number of breathing cycles per minute. At rest, the pulmonary ventilation is about 5 to 7 liters per minute, with the frequency of breathing as 12 per minute and tidal volume as 500 milliliters. However, during a maximum exercise, it may increase by 20 to 25 times to approximately 100 liter per minute. This can be explained due to an increase in both respiratory frequency to 40 to 45 breaths per minute, and tidal volume from 10 to 15% to approximately 50% of the vital capacity, mainly at the expense of inspiratory reserve volume, which correspondingly reduced during the exercise. The vital capacity tends to decrease in exercise since residual volume is increased while the functional residual capacity may remain unchanged. The total lung capacity may not change much after an exercise, although it may decrease slightly as a result of increased intrathoracic blood volume. The ventilation across the lungs or the pulmonary ventilation increases in parallel with an increase in oxygen consumption during a physical work. It may also increase with an increase in CO2 output, except during heavy load of physical effort when pulmonary ventilation increase disproportionately due to anaerobiosis of the working muscles, which contributes an extra drive to respiratory center. However, an increase in pulmonary ventilation during maximum exercise is always of a lesser extent than maximum voluntary ventilation. Now let's see how oxygen consumptions determine the cardiovascular efficiency. During a heavy exercise, the oxygen consumption increases to a level that is 15 to 20 times higher than the resting level, that is 250 milliliter per minute. This increase is due to an increase in oxygen delivery to the tissues. An increase in cardiac output marked an increase in alveolar ventilation, increase in capillary density, increase in RBC count due to splenic contraction. The maximum oxygen consumption or VO2 max depends on the muscle mass and functional dimension of oxygen transporting system. The VO2 max of an individual determines the maximum aerobic work capacity. That is, it is the best physiological indicator of the aerobic work capacity of a person. It may be defined as the highest attainable rate of aerobic metabolism during performance of rhythmic muscular work that exhausts the subject within 10 minutes. Thus, it becomes an excellent measure of our physical working capacity. During an exercise, a requirement of oxygen is much more than the oxygen transporting system can supply. Therefore, oxygen deficit develops. This lack of oxygen initially is paid anaerobically but compensated at the end by the cardiorespiratory system as oxygen debt. The pulmonary diffusion capacity of oxygen can be understood as the diffusion capacity of the oxygen to the pulmonary system is about 20 to 30 milliliter per minute per mmHg at resting condition. The diffusion capacity of the oxygen increases about 3 times the resting level during maximum exercise. This increase could be due to the increased blood perfusion around the air sacs of the lungs, opening of more capillaries, and increased surface area of contact between the alveoli and pulmonary capillaries. Now let's understand the muscular strength and how it can be a measure of the physical working capacity. The muscular contractions need energy to sustain any stress. An ability to produce the sufficient energy to the working muscles can be represented as muscular strength, and thus it can be a good measure of our physical working capacity. The only immediate source of this energy is ATPs, that is the adenosine triphosphates, and this ATPs must be continuously renewed. At rest and during a light exercise, oxidation of the fat in the form of free fatty acids produces ATPs for the muscle cells. As intensity of exercise increases, fat alone cannot fulfill the energy demands of our working muscles. Therefore, a breakdown of glucose and glycogen occurs to meet an increasing demand of ATPs, that is an aerobic glycolysis. With strong muscle contraction during a heavy exercise, the process of aerobic glycolysis also becomes inadequate. In this situation, anaerobic glycolysis started, that is breakdown of glycogen without the utilization of oxygen and production of lactic acid. ATP also gets regenerated from the high energy creatine phosphate stored in the muscle fiber. So, students, let's summarize what we have learnt from this module on physical working capacity. Now we have understood the concept of physical working capacity, and we have understood that the metabolic requirement of the body at rest or during the exercises are met by the oxygen supply to the tissues and the simultaneous removal of the carbon dioxide from the tissues. We have understood that the capacity to breathe, to transfer the oxygen to the lungs, an increase in the lung volume and capacity, increased cardiac output, and transport of the oxygen by the blood to perfuse the active muscles and to remove the carbon dioxide from the tissues during the stress conditions like the exercise or physical activity can help us to assess the physical working capacity. And we have also understood the methods of assessing the physical working capacity and what are the different physiological changes which are taking place in an individual's body during the exercise in order to assess the physical fitness of an individual. As we have understood that this helps us to study the physical fitness of the individual, therefore the competitive sports and athletes at national as well as at international level have a great interest in exercises physiology all over the globe. The physiologists have been very interesting in assessing the working capacity of the individual because it helps us to determine the physical fitness level of individual as well as of the population level. So far we have understood the importance of the physical exercises also, as that helps us to improve the physical fitness also. So a regular exercise and a physical activity level greatly improves the overall physical working capacity of a person. Therefore, it's very important to maintain a regular physical activity level and to exercise daily. Thank you.